Good morning, good afternoon, good evening, wherever you are in the world. My name is Curtis Govan. I'm president of North America for floLIVE. Thank you for joining us for a brief conversation on wireless networks for industrial applications. Our agenda is as follows. It's a pretty packed agenda, so we will dive right in. When we look at industrial IoT, as we do with any industry or any entity or vertical, we try to look at the decision-making entities and understand what they're trying to accomplish, one, and then the challenges that they have. For industrial IoT in particular, we see this as we do with other industries, and that is the fundamental conflict between IT and OT. Because these two different business entities have different perspectives on the business. Information technology, among all of the things that they do for a company, their fundamental concern when it comes to IoT is security. Security of the assets, of IP, cybersecurity, data, as well as the various operating systems that are coming into play for the solutions that will be deployed. So security is top of mind for the IT team. On the other side, the operational technology team, their really key element is working in concert with IT, but really bringing into fruition the promise of Industry 4.0. And that is ensuring that they've improved their operational efficiency, that they have the highest availability of their systems, that they're expanding capacity of those systems as well. And all of this while protecting the most important asset that they have, which is the people that are working in the facility there. So with understanding this perspective and some of the challenges they have, now we want to take a look at some of the use cases there. And what we have here is really kind of I call it the all-in-one use case for a facility that has a number of different applications deployed and sensors that are in place for environmental sensing for quality, operational monitoring, there for temperature and flow control and different aspects there. And then you may have some control systems that are actually controlling the elements that are doing the manufacturing pieces there, pumps, valves, conveyor belts, etc. And then we get into visual systems like image detection, where you're looking to detect flaws in the components that are getting manufactured there. You also have video that could be in place for safety. So someone comes into close proximity of a system there, you may want to slow down that system, or if you have bots that are going about in your facility, those bots may be redirected from an individual as well. In addition to that, you have video sensing solutions that are monitoring the robotic manufacturing cells, as well as the AGVs that are going around in your facility. You also have the need to automate material handling systems there, or control of the various bots within the system there. And then you have possibly the monitoring of wastewater and effluent for purity there. Now we get into kind of, when we look at logistics, that point that is, you have some internally mobile systems there with the robot, but now you have systems that are externally mobile, if you will, as they leave the manufacturing facility there. And you have a whole nother set of requirements that come into play there. So when we look at kind of like the overall components here of the use cases, what we see is that you really have a need to have multiple IoT devices that are connected, multiple systems that are connected. In addition to that, you have different third-party entities that need to have access to those systems. And then lastly, you've got a mix of static and mobile devices. Again, internally mobile that are moving around the facility, whether it be assets in the facility or robots, those are internally mobile. And then when you get into the logistics, you have pallets, you've got vehicles, you've got trains, you've got possibly things on airplanes, or moving across the water on boats or ships. So you have multiple different solutions that are required there. So if we kind of distill this down into the Industry 4.0 main drivers, we really see that you have really four components that are coming into play. One is improving operational efficiency, as I mentioned, is a key driver there. A segment of that, which is really important, and we found use cases here where this is actually one of the key components to operational efficiency, is simply location of equipment within a facility there. A lot of improvements can come by just knowing where tools are, where assets are, so you don't have to go and spend time looking at it. Reducing that time to find assets and tools is really critical to improving operational efficiency. And then next, we as we mentioned before, the increasing the safety so that the most important asset in a facility has the highest uptime, and that is the people. So that's a really key component there. And then lastly, we talk about here is industrial leasing, but really this could fit into the broader category of new business models. As I have seasonal business, or I don't have a high capacity, 100% capacity need for a facility there. That facility needs to know where its capacity is so that they can go and solicit more work to come into the facility there. So these are the key drivers there overall. And now if we look at kind of flip, now that we kind of understand some of the use cases and some of the problems, we take a look at the wireless technologies that are available to solve those problems. And one of the exciting things for us is that, I've been in the industry for over 2 decades now, and to see now where we have actual access technology that was developed specifically for IoT. In the previous years, we had technologies that were adapted for IoT, but they weren't specifically designed for IoT. With the advent, if you will, of NB-IoT and CAD-M, and now with 5G that promises literally everything, as we say here, you have technology that is specifically focused on IoT solutions there. And of course, with all of the solutions, as we noted before, you have a mix of requirements there. So whether it be the range that you have, so when you're deploying radio access network within a facility, or you have radio access network outside of your facility that needs to reach in, there are range considerations there. You have latency considerations for things like autonomous vehicles or autonomous bots that you have inside there, low latency requirements for pallets that are tracking that may have a 5-10 year life cycle that they need to support there. And then, of course, from a throughput perspective, the video cameras that need to have higher throughput versus the ultra low throughput of just a pallet that is just doing an update when it moves. So you have a lot of different requirements here, and this is just a few of the parameters that you would monitor. Of course, one thing that we don't cover here is cost, but cost certainly comes into play as you look at it. But what we really feel is that cellular technology is the best overall solution for industrial IoT. And I'll say that hadn't always been the case, but with the new technology and the new mechanisms to deploy that technology, we now see that cellular technology has edged ahead of all of the other technologies as a single solution that you can have to support all of your industrial IoT applications there. So as we look at that, one of the key things is we kind of go back and see what was previously available as a means of deploying cellular technology. And previously you had a public core, a public radio. It was a low-cost solution for certainly, and it was very easy to support both IoT devices, and it natively supported mobile phones, but you have no ability to control the quality of service there. And then you also have the challenge of coverage. If you're not in a good coverage area, you simply would have a facility that would have no ability to get that coverage. Well, the coverage component was solved by providing private radio. With private radio, now you can get that in-building coverage. The problem is that was an expensive solution and it was somewhat cumbersome to maintain. So the extension there is now the advent of private core. So you can have that core infrastructure within your facility or available so that you can route through there. That gives you the ability to control the quality of service that each of your devices has and balance that out based on what devices that are more critical versus devices that are less critical. So you can imagine the best solution is to have both. And that is the wonderful thing that's developed over the last 5 years, I would say, where you have the ability to deploy both private core and private radio at a very cost efficient price. Right? And you have the best of all worlds, in addition to the fact that you have a network resiliency that you ordinarily wouldn't have. And a good example of what's happened there, a use case I would say, is today you would be wholly and solely dependent on the mobile network operator's maintenance schedule. So if they did maintenance every month from 2 a.m. to 6 a.m., you would have a facility that was effectively down for 4 hours. Now you have the ability to control that by having your own private dedicated network. And that comes with a lot of benefits, some of which we'll cover here in the next coming slides. First of all, it's simply easy to manage. You have a management structure can be done on the cloud. So if you have multiple facilities, you can manage everything and control everything on the cloud. That could also be brought in-house if that's a security concern there. That could also be brought in-house. But the private facility allows you to have all of your devices and all of your employees' devices on a private radio access network and a private core. So if your employees are using their personal devices for monitoring systems there, they can be connected on your private core. And then when they go home, they could be on that same private core with their work information, but all of the rest of their information will be routed through a public network there. So tremendous benefit there to have that seamless environment for workers to be able to use their devices at the facility as well as at home, but then providing added benefits that we'll discuss here for the actual IoT devices. Multiple operator support in this case. So if you have your own private network, you have multiple operators that could be supported off network. So if you're having devices that, if we look at the logistics case that we talked about before, when that vehicle is in the pallets or whatever is in your facility, you have the ability to track it on your private network there. And then as you go off network, have access to multiple networks through one single solution there, not having to change that out at all. And then, as we mentioned before, not only self-management of the system, but being able to dynamically scale the system as you need to. You have full control over the private network. So if you see an increase in your capacity requirements there for the network, where you have thousands of devices that ordinarily would be hitting a public cell site, now you have those hitting your private radio access network, and you can expand that network as you need to and have full control of that. It's also something that integrates seamlessly with your IT infrastructure. In fact, it doesn't have to connect at all with your IT infrastructure. It can sit completely inside your physical facility, but be separated from your IT infrastructure there. So that means that it's wholly controlled by your IT team. Now, of course, one of the components here is now your IT team also has full control over who has access to it. Because when you have those multiple third parties that need to connect to the devices that they own and they're responsible for ensuring the uptime, they need to grab data from those devices to run AI ML algorithms on. You can have your IT team with full control over who gets access to that data and how they get access to it without giving them access to your regular IT infrastructure there. So an infrastructure that's solely dedicated to the IoT devices that you have within your facility. Of course, performance is extremely important there, where you're able to enhance the performance. You can get the lower latency. Great application there is a customer that has thousands of pallets that end up in one facility at one time. All of these pallets are on a 5-year life cycle. So they have battery that should last 5 years. And reducing that latency by putting, when it's in the facility, putting that core network infrastructure right next to their application helps them to extend the battery life. But also, as we mentioned earlier, you have now higher throughput requirements. So your video solutions, your autonomous vehicles are also going to experience that higher performance of the network. In addition to that, as we mentioned earlier, now you have quality of service that you can segment to your more critical devices, get the higher QoS, less critical devices like pallets that if I don't know, if they don't get a report in, I'm okay. I can live another day without getting that report. You can provide them with a lower quality of service and ensure that quality of service because you're not at conflict with other events that are happening outside of your facility. You know, the game show that has a call in and everybody hits the network there, or whatever incident may happen at a location that's near your facility that would cause a surge from the consumer mobile community. You're no longer impacted by that. And then the last piece that is a tremendous benefit is to have that same solution that you can deploy across all of your facilities around the globe, and have IT procedures that are applied to those different facilities. And then the other component there is that ability, as I mentioned earlier, to move seamlessly on the private network back onto the public network and vice versa. And that can be done with your IT devices as well as with your workers' mobile phones and personal devices, or devices that they have for use for work. Um, the other thing that's tremendously exciting is we've mentioned 5G. Like we're like many people in the industry, we're extremely excited about the prospects of 5G. We believe thoroughly that this will be a technology that will dominate the space, and that will increase the number of use cases that are available. The ultra low latency, the ultra reliability components, the super high bandwidth requirements up to 10 gigahertz theoretically that we can have. So we're excited about this. Like everyone, we're building for the future there. We see this as not something that may happen, but really 5G is imminent. There's some maturity that needs to happen, of course, with devices, but we're starting to see IoT devices come out. One of our partners in the industry has recently released an IoT, a 5G IoT module there. So we'll start to see more and more of those applications come into fruition, and excited about that. So cellular technology, in summary, here is that it's built for the future as well, and it'll allow you to provide those added use cases in the future, whereas other technologies will need to be adapted or replaced to meet those use cases there. So in summary, we're really excited. We believe cellular technology, if you look at all of the pros and cons of the different technologies, we believe cellular is really the best solution for its scalability, the coverage components that it has, performance, the quality of service that you can have. We mentioned network slicing with your ability to have your private network and even segment that network even further within your infrastructure if needed. So we're excited about that. We also believe that the key benefits of low latency, that smooth handover as you're going on facility and to off facility and vice versa, as you're having national and global coverage requirements there. All of that's comprised within the solution as well. And then the fact that we have the ability to deliver high throughput today with LTE advanced, and then beyond that, 5G will provide even higher throughput for those devices that need that. And then lastly, as we've mentioned several times, that quality of service that you're able to segment and have full control over in your mobile private network. Those are the things that we believe make cellular really the technology that's best suited for industrial IoT. So that concludes our time today. Thank you for joining us. Hopefully, you found some of this insightful. We'd love to have a conversation with you and help you along your industrial IoT journey. So if you're interested, please feel free to give us a call. Thank you so much.